start. If I'm looking at this part, I see that cylindrical boss down the center, probably something I'm going to start with. I'll take a look at that. And then I see this base plate at the bottom there, and that has some hole locations, 80 millimeters in each direction, and it's got that big 75 millimeter radius at the top and a couple of holes. And that looks like I either pattern that linear pattern or maybe I'll do a circular pattern for that. Next thing we're going to do, we're going to shell that out. If I look at this, that whole bottom pocket there, that whole bottom piece is basically a shell, but I don't want to show all the other stuff at the top. Then we're going to put this clamping boss on the side. So you can see the dimensions that are located for that there. We'll go ahead and add that. Then I'm going to add the fillets. I'm going to add the fillets before I put the saw cut and the holes in, and we'll see why I do that. It makes it a little bit easier for picking the edges or the faces that I need to fillet. The last thing I'm going to do, or not the last thing, next thing I'm going to do is I'm going to add a 3 millimeter saw cut that kind of opens up my part so I can do the clamping. Next, we got some holes. So I have an 8 millimeter a counterbore for a M8 socket head cap screw, and on the far side I have that tapped hole for that same thing. And then we're going to apply our material, and the last thing we're going to do is we're going to run our simulation. So let's get started. Let's actually walk through do a little run through of how we would actually go through this here. I'm going to start on the top plane. Again, that big cylindrical boss that I had there, that's a 50 millimeter diameter on the inside, 60 on the outside. And I'm just going to put everything in a single sketch. One of the things I'm going to do is I'm going to locate those holes that I had out there. The diameter is 14 millimeters and 12 times 2 or 24 for the radius of that. And the reason I'm adding that here is I want to put everything in this one sketch because it's going to help me. I think it's going to help me later on. So 40 and 40, I want to pattern that around. I'm going to use the sketch pattern here to do that. But before I do that, what I want to do is I want to add this arc here. That's a 75 millimeter arc that I'm going to add. Actually, we don't even add the dimension, but I want to make sure that's tangent because I'm going to pattern that around. Now, one of the things that helps me with my pattern here is I have that center line that goes to the vertex, the center, the origin of the part, and that helps lock everything down. You could do the same thing without that line in there, and you'd see what happens. We'll attach that arc to the circle on the side, and we'll add a tangent relationship and a dimension of 75, and we'll extrude it. I'm not even going to trim anything up here, just going to use the contours, grab these contours here. We're going to drag that out. That's going to be 20 millimeters in depth, and there we go. On the bottom, I'm going to shell that out. So while it's still early here, I'm going to go ahead and shell this. 5 millimeters of wall thickness there. Go ahead and shell that out. Next, we're going to take that same sketch that we started with, and I'm just going to drag that inner cylindrical boss, if you will, those two circles, and just drag that up. That's 60 millimeters. Now we'll put on the clamping boss, that angled thing that goes on the side, transition immediately into an arc, just transition away at tangency there, and just draw out my shape. This is going to be 12 millimeters is the dimension for that, and then I'm going to add a dimension of 30. And then in order to get symmetry in this part, I'm going to create a center line between the center of that arc and the midpoint of that line and make that line horizontal. That establishes my symmetry for me. We'll add some dimensions here. It's going to be 36 millimeters from the central axis, and then from the bottom it's going to be 42 millimeters to locate that. I still have one blue line under constrained line. I want to go ahead and constrain that, so I'm going to do that by turning on or turning off my shaded and turn on my wireframe, and just go ahead and lock that onto that inside bore. Now I won't have any extra material on the inside. Here I'm just going to use Instant 3D and drag that out. And a tip I learned from Buzz on Monday is that I can just use the M key to hold that down, and it builds a midpoint relation, or makes that a midpoint relationship there. When I see these extra little faces like that, first thing I think of is delete face. I got this extra little geometry, delete those two faces, use the selection helper to get the all planar faces, and it chooses both sides for me, and there we go. Now I'm going to add my fillets. All I had to do is choose that one face, and it wraps that fillet all the way around that part for me. We'll choose the bottom face, one of those vertical edges, and then use the selection helper to get all the other 7 that are very similar to it. It saves me some steps there. Now this isn't necessary, but it helps me for visualization, is to give color to that fillet, that feature there. And you can see then I can see all my fillets kind of wrap around my model as I'd expected. I'm not missing any edges. And actually, when I grade these parts, I'm always looking, highlighting that face so I get that color so I can see, make sure that they're all there. Next, we'll add our saw cut. So this is just a line, a single line that I'm going to draw, and I'm going to make that I'm going to make it I'm going to do a cut, and it's going to be a cut with a thin feature about the mid plane of 3 millimeters wide. Now we're going to put our use our hole wizard and put those holes in there. This is going to be an 8 millimeter counterbore hole. So we use a socket head cap screw, use all the capabilities of hole wizard to define that, so I don't have to model that in there. What I'm going to do is I'm going to turn on my temporary axis. It's never a good idea to tie a hole or a feature to an edge of a fillet. So I'm going to locate that hole to the temporary axis, so that makes that a little bit more robust of a model. Next, we'll add the tapped hole. This is going to be an M8 tapped hole through all up to next. Either one works. Locate that on that temporary axis as well. And now we're good to go. So the last thing we need to do is check our model, make sure everything looks good. We need to make sure we apply our material, and that is going to be plain carbon steel. And there you have it. We've finished the model. Now, the next thing we ask you to do is run a simulation. So let's go ahead and do the simulation portion now. You could use SOLIDWORKS Simulation or Simulation Express. I like to use SOLIDWORKS Simulation. We're going to hold with fixed geometry type of restraint the 4 holes that kind of locate this thing, and those are called out on the drawing. Those are going to be held as fixed. And then we're going to apply a force to the inside bore of this thing, and it's going to be defined in a certain direction. And I'm just going to choose that edge to define the direction. We'll reverse that. 10,000 newtons is the load that we apply. And our model is set up. The last thing we need to do is hit run. And there it goes. It's going to go off and run. I always like to, we'll turn off our symbols here. I always like to animate my simulation to make sure it behaves as I'd expect. And sure enough, it does. So let's solve for our factor of safety, and it's around 3.3. This number varied depending on your mesh settings. That's something when we're doing this live at World, I have control over the mesh settings, and I have control of setting that up. Everybody's machine's different in the real world, so the factor of safety did vary a little bit, anywhere from 3 to 3.5. All those are right. But what I do is I always go in and check to make sure your loads and boundary conditions are defined correctly. And that's really what I'm looking for there. So there you have it, Modelmania 2021.